Well, hello, this is Brunky Tech. Today we will be talking about hard drives or non-volatile memory for your PC build. So what are today's available technologies for hard drives? How do these operate? How do I know if these hard drives are compatible with my PC? And what combination of hardware is most cost effective for my build? All right, first we're going to start off with the hard disk drive. This is an electrical, mechanical data storage device that stores and retrieves data using magnetics. Each HDD comes with a pair of magnetic heads which are placed on the end of a moving actuator arm. The data bit is set by the head by using magnetism, setting every single bit to 0 or 1. This technology was originally invented in 1957 with the IBM 305 RAMAC system. This hard drive stores 3.75 megabytes on a stack of 52 disks. Weight of this behemoth was over 2,000 pounds and needed a forklift in order to move. So new solid state drives come on sizes of 2.5 and 3.5 disks. The interface between these drives and the PC is the SATA 6.0 gigabytes per second, or the SATA 3. The speed of the drive usually operates at 5,400 or 7,200 RPMs. Typical price of these drives is around $40 per terabyte and are the cheapest per terabyte. Power consumption for use on these drives remain kind of high in idle and operation state. The interface for these are SATA 3 and or USB. The unique feature for this device is it is capable of storing data in its off state indefinitely, meaning once the data is set, it does not require a charge to retain data. The combination of indefinite data retention coupled with decreased price per terabyte makes these drives popular for long-term storage. All right, so NVM, stands for non-volatile memory. So let's talk about this real quick. Data can be either retained on a power down or moved from memory once power is removed. Your hard drive, you want to store and keep that data in comparison to your RAM, which erases the memory every single power down cycle. So for solid state drives, the memory holds its state on power down. So when power is removed, the switch of the FET retains its value with capacitance.
Unlike a hard disk drive,
these devices require a temporary refresh from voltage for it to retain its data. Solid state and NVMe drives need an occasional charge for it to retain its data. NVM drives come with a controller that bridges the drive to the main PC. This controller executes firm level code which communicates with the computer to deliver the desired data. These microcontrollers have been used to spoof the recipient of a device holding far more storage than it was capable of. A solid state drive, or SSD, is a computer storage device that retains data for your PC. Like the name suggests, the counter to the hard disk drive, this device has no moving parts to function. The original solid state storage device was built in 1978 Storage Tech STC 4305. This device can store 45 megabytes of data. The price for this device was $400,000, but was half
the cost
their disk counterparts and 7 times faster.
The following specs are for the solid state drive that is utilized through the SATA 3 port.
The price for these drives are far more pricey than the older technology. You can expect to pay about $75 per terabyte for the latest and greatest. Typical read-write speeds are 3 times that of the hard disk drive. The interface is the SATA 3 6 gigabyte cable or USB. These devices consume far more less power while active than any other technology. So now we have the NVMe, so non-volatile memory express. So traditional PC storage slowly became the largest bottleneck of your computer performance. So this is why in 2011, the NVM Express work group
collaboration with more than 90 companies, released the first specifications for this new hard drive. In 2013, the latest PC began to roll out with boards capable of utilizing this new technology. Since then, the Express cards have gone through the M 1.0 and the M 2.0 revision. The latest release version M 2.0 works as a PCI Express 3.0 and up to 5.0. Unlike other standards, a card built on the M 2.0 specifications can run at the express lane covered under the spec. The downside is the card will only run at the speed of the interface. So let me give you an example. The latest released M 2.0 is Express 4 card on the Express 5. It will still function and work as normal, yet you'll be limited to the speed of the 4.0. The other scenario is also possible. You had a PCI Express 3 motherboard and a PCI Express 4 card. When you put that card in that 3.0 motherboard, it can only run at the 3.0. So the current release spec for PCI Express 4.0 are as follows. You can expect to pay about $85 for a terabyte card. The power consumption is far less than any other storage device. So as far as any new technology, the read and write speed far surpasses any other generation of device. For the M 2.0 socket, we can run 3.0, 4.0, or 5.0 Express. Unlike the SATA drives, the number of NVMe drives are limited to your board. So typically, when you get a new motherboard, it's going to have 3. So there are also expansion boards that allow you to increase the number of NVMe drives you can use on your computer. So one thing you need to remember and keep into account, 4.0 Express and above, you'll need to install a heatsink. Most board typically comes with this already installed. Put your drive in, you peel off that little sticky tape on the back, and you put it on. So ultimately on your new PC, what are my recommendations moving forward? So you always should use an NVMe drive for your data storage, and you should use the first 3 slots that you have on your PC. Get a 1 terabyte card for your operating system, and then as you slowly work along and need more storage, fill up those other M2 slots. So if you go and surpass what you need there, I would look into getting a hard disk drive. The reason behind this is they are far cheaper than the alternatives and the ability to store far more data for a cheaper amount of cost. Once your memory is on the hard disk drive, it should be something that you rarely access. So for example, if you create a YouTube channel and you have a lot of YouTube videos that you want to store over time, I would actually recommend putting those on a hard disk drive where you can train and retrieve that data at any time later on in the future if need. Thank you for tuning in.